Okay, and I think it's time. It's time to invite our first speaker to our board. So, guys, let me introduce you our first speaker of Javon 2023, wonderful Grace Jansen. Hello, Grace. Welcome to Javon.
Hi, thanks so much for the invitation.
We are glad to having you. Uh, can you maybe give us some hint? What would your talk be about?
So, we're going to be looking at combating some of the challenges and the struggles that we face as modern cloud native Java developers.
Okay, okay, sounds really interesting.
Yeah.
So, do we know how many Java developers already fought in this battle with cloud native? What is the
I,
percentage?
I feel like even if you're not using it in your day job, because I understand that some people are still on premise, or you might be using monolithic, but we're developers, we're curious, we love innovation, so you're probably already trying it in your free time, or at least as a side project or something fun to do. So you're probably struggling with it in some other sense anyway. So I would say almost 100% of developers have at least tried it in some sense and come up against these struggles and these frustrations. So hopefully, this presentation will give an idea of maybe where things like platform engineering, internal developer platforms, how these can come into play, how they can help. So hopefully it'll be an interesting presentation. I appreciate you guys all joining me today.
Yeah, I'm pretty sure, and I also heard and want to agree with you here that if developers are not fought in this battle with cloud native, they at least thought of that and it's like, okay, I tried to run my cloud native build locally. It took me like 24 hours. I shut down my laptop and went away. So that's definitely what I heard.
Yep. I think that's something that a lot of us have experienced before, and hopefully there'll be some gifs and some memes that I think sum up our feelings quite well. So hopefully you'll see them throughout the presentation and relate to those feelings.
Okay, I think we can not waste time anymore and just dive into the first talk of Javon 2023. So while Grace, we ask you to share your screen and we move it on the board. Guys, again, thank you very much for being today with us today, tomorrow, and on Friday. We're really glad that you are with us. So your questions, please post them in YouTube and in chat and Wear community. We will monitor all of them. And in the end of the talk, we will ask all these questions. We're here. Grace, good luck, and let's go.
Great. Thank you so much, guys. And thank you to everyone who's joining today. I know you guys have super busy schedules. And so I appreciate your time today joining the Java On conference and joining my session. So yeah, my name is Grace Jansen. For those of you who've not met me before, I'm a developer advocate at IBM based in the UK. You'll have to excuse my voice a bit. Sorry, I've picked up a bit of a cold or something, but hopefully we'll get through this presentation without any issues. So I've had a bit of a weird journey into tech. I actually did a biology degree, mainly focusing on fish and marine life, and then moved into the world of technology after graduation and sort of have moved into this world of Java and then into the world of cloud native. So I've kind of seen this from a different perspective, coming in without perhaps prior knowledge or prior experience on more traditional monolithic style applications. So it's been interesting for me to observe from this sort of outside perspective in looking at some of the struggles and the challenges that we now face as a development community in Java when we're trying to develop modern cloud native applications. And that's what we're going to focus on today, and how things like, as I said, platform engineering, IDPs, and sort of technologies and tools that are available for this can help us when it comes to sort of trying to tackle these issues and these struggles. My Twitter handle is there, so if you don't already follow me on Twitter, feel free to do that. Twitter, X, whatever you want to call it. I'm going to try and get around to your questions at the end. If I don't get around to them, then please do feel free to tweet, tag me, message me, however works best for you. So without further ado, let's get started. So the first question I want to ask is sort of, why do we care about trying to get our applications onto the cloud? Why are we trying to develop these modern cloud native applications? And I think it's this feeling. Hopefully you're familiar with Toy Story, so you'll understand this. If not, go and watch Toy Story. Great movie. It's this feeling that we get as developers, this, ooh, the cloud. We get excited about the cloud because the cloud allows us to have all of these innovations, these key behaviors and characteristics like flexibility, portability, scalability, resiliency, the innovation within the cloud that we can take advantage of by being able to utilize it through platforms. So all of this gets us excited. And that's why We want to be able to take advantage of all of these key characteristics in our own application by developing for the cloud. However, it doesn't always feel like this. It's not all butterflies and roses and sunshine. A lot of the time, how we feel and what we were just discussing is actually when we're developing cloud native applications, we feel a bit more like this. It's frustrating. We can't get our builds to deploy. It works on my machine, but it doesn't work in the cloud or on someone else's. It can be a very frustrating process developing for the cloud. So how can we turn this back into this? And hopefully this is where platform engineering can help us a bit with this. So here's the agenda for this presentation today. We're going to take a look at how we got to this position in the first place, looking at some of the developer struggles that we currently face, and then we're going to dive into what platform engineering is, how it can help us, what internal developer platforms are and how they're different to internal developer portals and how they all fit into platform engineering. We're going to take a look at what benefits all of these offer for us as developers and some of the tools that we can utilize to be able to perhaps start this journey towards platform engineering, or at least try it out, check it out, and investigate. And then at the end, I'm going to have a summary and some helpful resources in case you want to further your learning and go beyond just this session today and learn a bit more about the topics that we're covering. So what the hell happened? So let's have a look at how did we get to this position in the first place? So I quite enjoyed this meme because I felt like it sort of embodied many of the spirit of developers when it comes to this sort of attitude towards, well, we'll just shift everything left. And this increasing cognitive load that we then face as we're moving so many responsibilities back to the development team itself. You know, this sort of shift left mentality of, well, now that you're building it, you should also run it as well. But kind of this feeling of, I just want to run away instead. So the fact of the matter is, as we've moved towards modern cloud native development, we've started moving towards not just app development. We're now, as well as having sort of, well, we used to have traditional dev and ops teams, and we sort of chuck it over the fence and not really deal or look at what happens once we're trying to deploy it. Now developers are expected to enter a world of DevOps, FinOps, MLOps, GitOps, DataOps, DevSecOps, BizSecOps, BizDevSecOps, BizDevSecFinMLOps. Could there be any more ops? This list just seems to be ever growing. And what it results in is this shift in responsibility that increases our cognitive load as developers. So if we take a look at traditional app development, here's the split that we kind of used to have traditionally in app development. So you can see the light blue is the dev responsibilities and the dark blue is the ops responsibilities. So here we have developers looking at mostly the applications and maybe a bit of the app build. However, on the ops side, developers are very happy. They get to focus on what they love, creating innovation in the application. But on the other hand, the ops side have a huge number of responsibilities here that they're trying to deal with, and equally are getting little to no help from the development team because they're just chucking it over the fence. However, as we start to move towards cloud native and modern app delivery, what we tend to see is this shift of a lot of the responsibilities now moving onto the shoulders of developers in line with those different types of MLOps, DevOps, FinOps, etc. So now dev is kind of responsible for a wide variety within the app lifecycle. So not just applications, not just app build, but now we've got to look at things like how do we deploy our app? What runtime are we using? What Java are we using? Guest OS. We might also be partially involved in the entitlement or the billing because we're deploying to the cloud, and we've got to be aware of how much we're spending in that regard. And on top of this, we now have increasing demands when it comes to the application on things like usability, quality of our code. Are we able to observe our code when it's being deployed to these distributed and remote environments? So suddenly we've got a heavy load onto our dev team. And on top of that, our ops team's now trying to get their head around Kubernetes. Maybe they're using Docker, for example, containerization. How do we now deploy into this cloud platform, this cloud environment, and all these new skills that they're going to have to pick up as well? So we've kind of got a stressed out dev and an op that's having to learn a lot of new skills and isn't necessarily comfortable in this environment. So where do we go from here? This sort of movement, I liked this quote that was from Humanitech's Luca Galanton. The movement to shift left has forced developers to have this complete end-to-end understanding of an ever-increasing amount of complex tools and workflows. These tools are often infrastructure centric, meaning that developers have to be concerned with the platform and the tooling their workloads run on, as well as the application itself. So it's this huge growing amount of cognitive load that we're having to take on as developers, which is really leading to burnout, frustration, and sort of this feeling of the fact that you're never going to be able to understand or take a hold of everything. And this sort of quote leads on to the fact that it's not just about cognitive load. It's also this ever increasing amount of tooling or choice that we have when it comes to how do we do each part of our software lifecycle. There is so much choice. In fact, there's so much choice, I made a little game out of it. So a clear example here is the cloud native, what I like to call grocery store, but this landscape that's been produced by the CNCF Foundation. And I've added Waldo or Wally to this just to show how hard it can be, even to find one single tool in this mass of many, many, many tools that we can pick from for various different aspects of our app development, whether it be the runtime, the underlying platform, the infrastructure, the observability, whatever part it is. There's a huge choice that we can choose from in terms of the tools that we use for these things. So I'll see if any of you guys can spot it. Do let us know in the comments if you can. I have made him slightly bigger than some of the other squares, so you should hopefully be able to see him given a bit of time if you really zoom in on your screens there. But for those of you who weren't able to spot him, here he is. But the whole point of this exercise was, there is a wide array of tools. So not only do we need to be learning many different other responsibilities and aspects of the software development lifecycle, but we're now also having to take on responsibility of which tools do we pick? Are they right for our application? Do they meet the requirements that we have? Do they meet the regulations that we have to keep up with? So it's a huge array of choice out there that we're now having to also comprehend and deal with. And this leads me on to some of the developer struggles that we face. So one developer struggle that I wanted to sort of point out is this CI/CD tooling. So I quite enjoyed this meme on the right here. Again, hopefully sort of a lot of you will relate to this whole, you start to learn Kubernetes and then you think you're almost there, and then you discover Docker and you're like, right, that's another thing, I'll learn that. Then you get to Kubernetes and you're like, oh yes, okay, I know Kubernetes now, I'm ready for cloud native. And then you realize that there's a whole load more to cloud native than just containers, Docker, and Kubernetes. So it really is a steep learning curve in terms of our CI/CD tooling, and it takes time for us to be able to learn all of this, as well as the fact that there's so many options out there for us to choose from when it comes to which tools we use in this sort of pipeline that we're creating. Even when we start looking at open source standards that are supposed to be sort of the standard, there's still a plethora of choice, which does make it hard for us to be able to pick just one or make sure we're picking the right one for our application. And then on top of that, we've got to think about, okay, now we're deploying into this remote distributed environment that's often complex and chaotic. How do we make sure that we're able to effectively observe our applications to make sure they're behaving as we intended or as we expect them to? So again, all of these make CI/CD tooling aspects quite difficult for developers, one of our struggles or one of our challenges. Another one is container management. One doesn't simply run a container. It's not quite as simple as this. There's a lot that goes into running a container effectively, especially when we're deploying to the cloud. This includes not only ownership of that container, but also things like cost. We're now having to work as a DevOps team rather than just separate ops. We have to be thinking about the ops side of this. So how are we deploying and maintaining and running these containers in production? The great thing about containers is obviously it gives us that portability and flexibility, but there are many decisions involved when it comes to running and maintaining our containers. Which tools do we make use of? How are we configuring our environment? Is it as efficient as possible while still allowing for that high flexibility, resiliency, and high performance as well? How do we build our apps and enabling that within that container management system? It's also challenging when we have this ability to be able to run as separate teams within our own organization, developing different parts of the same application. It's challenging for us to be able to ensure consistency and stick to best practices across every environment that we have, across all of our teams, when we have such flexibility in which tools to use, configuration options, and sort of where and how we're deploying our containers. There are tools that can help us a bit with this. So things like operators, for example, or cloud native build packs can help, especially when it comes to sort of knowing what images that we're using, where if they come from, for example. And I've actually done an article on cloud native build packs. So if you've not come across this before, this tool, check out the article that I've linked to at the bottom of this slide. It runs you through what a cloud native build pack is and how it can be helpful. However, this doesn't solve all of our issues, especially when it comes to consistency, best practices, and sort of simplifying this process, because there's still a lot to be considering and to sort of a lot of cognitive load in this task here. And another one is security and regulatory requirements, which sort of links to those best practices that I was talking about before. When an organization has created a product and they want to sell it to sort of a large enterprise, excuse me, it often requires things like compliance certifications before you can actually GA it or sell that in a specific market or a geography. So things like the Data Protection Act, especially for healthcare data, ensuring that we're complying by specific geography regulations, like we might have to have our data hosted in a specific location. And on top of that, there's also the fact that we have to be considering things like, well, many of us are utilizing open source software. Do we know what is in our applications? Excuse me. So having a software bill of materials to be able to understand what's actually within our application. Is it safe? Do I have vulnerabilities that I need to be aware of? Do I know where I'm getting this software from? Is it a trusted source? Having that understanding of, are we aware of the vulnerability, not just in our own source code, but in the images we're using or any external libraries that we're dependent upon? Do we have a trusted software supply chain? And do we have any compromised credentials, for example, in our own source code itself? Excuse me. So these are all struggles and concerns that we face as developers. On top of this, there are also other struggles. So for example, the likelihood is you're probably already drowning in scripts and maintenance costs. You might say today you'll just hire more DevOps, but this doesn't really scale when we're talking about huge, large organizations. Another thing is, no matter how hard you try, you'll probably not reach the degree of automation possible because you don't have the necessary scale that you want. Another struggle that we face is key person dependency. Often you'll have a key person so that you will be dependent on, whether that be in ops or another team. So any maintenance update depends on someone who knows exactly what configuration to change and in what file. This works great in the first year, but the average job time in our industry is just 1.4 years. So this constant churn, as well as the fact that we're dependent on this person, and they may not necessarily have the skills or the knowledge right away, can cause that blockage or that potential bottleneck in our sort of software lifecycle. On top of this, every time a dev needs a new environment, they have to interrupt a colleague, often in ops, and wait for its creation. In the most extreme example, we've seen an automotive company that took over 3 months per process. So it can be a really long time, depending on how your organization works, just to create that new environment that dev might need. And environments can also get blocked in testing. If you need to ship something, you then can't. If you have to run a hotfix, your team is out of the game entirely. So these are all struggles that we face on top of those other 3 that I was talking about when we're trying to develop effective modern cloud native Java applications. And all of this put together can make us feel a little bit like this. Okay, this might just be me, but this feeling of like, I don't want to deal with it anymore. It's all too much. And this isn't just me feeling this way. There are studies out there that have shown, so for example, this is Salesforce. This is a study by Salesforce in April 2022 that shows that the top 3 causes of developer burnout includes increasing workload, like I was talking about, all those responsibilities shifting onto us from other teams, pressure of digital transformation. We are trying to move to the cloud, and this also increases pressure on us as developers to get our applications there, and requirement to learn new skills. There are a bunch of new tools and skills that we need when it comes to deploying our applications and developing applications effectively for that cloud native environment. All of these 3 are the top causes of developer burnout. In fact, 76% of organizations in this study say that the cognitive load is so high that it's causing angst and actually low productivity for their developers. So having a negative effect on their overall output. So clearly this isn't just me coming across these issues and observing them. This is being observed in many different organizations around the globe as we're moving towards these cloud native development. I quite enjoyed this Twitter poll from Luca where he was saying, devs do we really want to be doing ops? Like, be real with me. I enjoyed some of his answers that were applicable there, but the answer here is the majority of people in dev didn't really want to be bothered with the ops side of things. A lot of developers just want to be developing applications, going back to that happy dev that we saw in the previous sort of traditional style of application development. However, we do need to innovate and we do need to move towards the cloud. So how can we utilize methodologies and tools and principles to be able to go back to the sort of happy developer, but still enable this innovation? And this is where things like platform engineering can help. The fact is that most developers require the same sort of technologies, and often it can be standardized across the board. For instance, let's take the consolidation around Kubernetes and containers, infrastructure as code, and the need to implement sort of similar build configurations and security policies across applications. This could potentially be standardized across your organization. So by outsourcing the maintenance of tools for shipping and running your applications to a common platform, we can then hopefully take the burden off developers and free them up to focus on their code. So it's kind of this idea of platform engineering is all about kind of centralizing DevOps tooling to help us enforce more governance and build out internal standards, which can help with reusability and overall deployment agility. This is a growing topic of conversation, one that's really become sort of at the forefront of many organizations' minds as it moves up in the Gartner hype cycle. So as you can see, it's here in the sort of innovation phase right now, but it is expected to move up into this sort of peak in the next few years. This is the hype cycle for software engineering from Gartner from 2022. So you can see it is growing in popularity within organizations. So what is platform engineering specifically? What does this phrase really mean? So this comes from platformengineering.org. Platform engineering is the discipline of designing and building tool chains and workflows that enable self-service capabilities for software engineering organizations in this cloud-native era. Platform engineers provide an integrated product, most often referred to as an internal developer platform, covering the operational necessities of the entire lifecycle of an application. So from this, I've really pulled what I think are the key aspects of what platform engineering really means. Essentially, it allows us to have these sort of workflows. Often they'll get referred to as things like golden paths or paved paths that enable self-service capabilities. So we're no longer having this key person dependency. We can self-serve as developers ourselves. We can self-serve into the cloud. And this is all enabled through this concept of an internal developer platform, which we'll get onto in a minute. So really, platform engineering is this discipline that's focused entirely on sort of enhancing developer productivity and happiness, because we're going back towards that, just focus on your code. We'll automate the rest. We'll standardize the rest. It's this sort of developer first infrastructure sort of principle that we're trying to follow and improve this developer experience. So the aim of this is really to reduce the complexity and the overheads while enabling frictionless and self-service capabilities for organizations who are trying to develop cloud-native applications. Many of you might look at this definition and say, right, okay, well, DevOps, we've seen on the Gartner hype cycle, DevOps is platform engineering is growing in popularity. Platform engineering is the new DevOps, so that must mean DevOps is dead. We've got to move on from DevOps. Actually, I'd argue that DevOps isn't necessarily dead. I quite enjoyed the summary that's provided in this meme here. So we start off with this phrase of, well, platform engineering is the future, DevOps is dead. But then we realize that actually we need to utilize DevOps practices and tools to actually build the platforms that we need in platform engineering. So we still need DevOps. It's just evolved into this concept of platform engineering. It is often quoted as the next evolution of DevOps, but this practice doesn't necessarily supplant it. It just is the next evolution. It's something to consider that actually, if you're already utilizing DevOps in your organization, you can utilize that within platform engineering as well and still use the same tools and skills to be able to ensure you have great platform engineering, great platforms. There are actually considered 6 foundational pillars that comprise sort of platform engineering, and you'll recognize many of them from DevOps principles. So we have things like security. The first thing a developer asks when they start using any system is, how do I create an account? Do I need to set up credentials? How do I get an API key? Talking about the security behind your application and making sure that that's first and foremost when you're setting up your platform engineering platforms, so that That's consistent across everything that is involved in platform engineering, talking about security right up at the forefront to show how important that is. We've also got things like pipeline. So one of the first steps in any platform team's journey is integrating with or potentially re-architecturing the software delivery pipeline. So taking a detailed look at an organization's version control systems and continuous integration and continuous deployment pipelines. There's also then provisioning. So in these first two pillars, so security and pipeline, the platform team is providing this sort of self-service CI/CD pipeline workflows with security baked into them as guardrails right from the outset. These are the first few steps, but once you have the application code to run, the next question is, where are you going to run it? So every IT organization needs an infrastructure plan at the foundation of its applications and platform. So then platform teams, this is what this provisioning pillar is all about. It's about providing the way in which that we can essentially enable that infrastructure. Where are we going to be deploying that application? Then we go on to connectivity. So network connectivity is often hugely undiscussed in terms of DevOps, with many legacy patterns and hardware still in use in many enterprises. So it's important that we add this as a key pillar in sort of platform engineering. And this brings sort of the automated speed, reliability, and version control traceability benefits of infrastructure as code to networking. So it really allows us to be able to connect into sort of modern dynamic environments and bring networking functions, softwares, and appliances into their infrastructure as a code configuration. We then got orchestration. So when it comes to actually deploying your application workload, if you're working with distributed applications, it's going to be much easier using a workload orchestrator. So enabling that through this sort of pipeline that you're building, this platform, as you will. And then the last one is observability. As I mentioned, really key for us to be able to observe how our application is performing in reality when we're deploying it into these distributed environments. So observability is that last key pillar. If you want more on this, there is actually a white paper that I've linked to at the bottom here, which goes into each of these in a great deal of detail. So do check that out if you are interested. So essentially, by going through each of these pillars and considering each aspect of them, we're going to be putting together our own sort of platform engineering pipeline or platform for developers to be able to utilize in our organization. Essentially, you can think of it kind of like you're collecting together ingredients to be able to bake your own platform. So the key ingredients that we need for the platform engineering recipe are dictated by the sort of tools that we need to utilize in every aspect of our software development lifecycle. So it goes right the way from, okay, which IDE do we want to standardize? Which one are we all going to use? Through to, okay, what version control system are we using? Are we using GitHub, GitLab, whatever it might be? Going through to resources, container registries, for example, which runtime are we making use of? Going through to observability, so we're using Instana, Dynatrace, Datadog, looking at vulnerability scanners, CI/CD tools, things like GitOps tools, for example, infrastructure as code, if we're utilizing that, like Terraform, Ansible, Pulumi, Crossplane. There's lots of different ones to choose. So it's all about collecting together the ingredients that you choose in your platform engineering team for your whole organization, so that you can then bake together this platform for your developers to be able to use as that self-service platform. So once you've picked together all of these things, this is where it all comes together in these different aspects of the software development lifecycle. You can see here, this sort of, again, we're going back to DevOps principles to be able to bake together your own platform. So the way it looks is a bit like this. So we take all these ingredients together, we're baking them into this internal developer platform, and the developers are able to access this through the internal developer portal. The internal developer portal and the platform and sort of who chooses the ingredients might differ depending on how your organization is set up, but often you'll have a platform engineering team who's in charge of this process. They're taking on the responsibility of these aspects of this software delivery lifecycle. So what do these individual parts actually mean? We've spoken about internal developer platform and about internal developer portal, but what are these definitions? What are we talking about here? So when it comes to an internal developer platform, I've shortened this here to IDP. Now, we're in tech, we absolutely love acronyms. You might hear an internal developer portal also referred to as an IDP. Little bit confusing. So I just want to make sure that we're clear that in this presentation, I'm talking about the platform and not the portal when I say IDP. What this is I've taken this diagram here from Configure8. It's a company that offers a proprietary IDP. And as you can see, I thought I liked this diagram because it kind of showcased that IDP being in the center there, the developer portal connected to it to act as sort of a face, which we'll go into in a minute, and those different various plugins and sort of infrastructure that's sort of connected into that central platform that we're able to utilize through it. So what an IDP is it's a central collection of tools, services, and automated workflows that enable development teams to be able to rapidly deploy and deliver software. They provide a service layer that helps to abstract away the complexities of infrastructure management and application configuration. So it really allows us to be able to sort of minimize the cognitive load for developers without abstracting away important meaning. The key part here is sort of why these three words were chosen to describe this. Internal, it's trying to make a clear separation between this type of platform and an external facing platform, like Twilio's developer platforms, for example. They are external facing. IDPs are meant for internal use only. Developer, really indicating the internal customer and the primary user is going to be the application developer in your own organization. So making sure you have that focus on this is a platform for developers internally in my organization, and platform just characterizing the product type. So platform engineering is about delivering products to development teams that allow them to focus on the problems they're trying to solve instead of solving the problems of how to actually deliver the solutions. And IDPs are a way of enabling that. They're custom built by a platform team by combining different tools and technologies together. And they might be services, they might be open source, they might even be self-developed, whatever it might be, with the intent to then increase developer productivity and velocity. So IDPs allow us to be able to have these golden paths or these dedicated workflows that are already paved out for us. So as developers, we can just jump right on that bandwagon, follow that paved or golden path to be able to easily get our application up and deployed into the cloud, utilizing infrastructure that's already been approved. How are they used by developers? They actually integrate right into our existing workflows, which usually remains a sort of a git push deploy workflow, but with some further automation added in. The entire deployment process is now at the disposal of the developer, hopefully, so they can request resources, spin up fully provisioned environments, they can roll back, deploy, and set up deployment automation ruling all autonomously through this platform. So a modern developer should only need really 3 panes of glass: the IDE to code in, Git to be able to merge any code that we want to merge, and an IDP to be able to actually ship and run it. So that's where it kind of comes in terms of the workflow. But it should be really straightforward and easy to use. Often, this last pane of glass comes to us in the form of an internal developer portal. You don't necessarily have to have one to utilize internal developer platforms, but they can be a really useful tool to use to be able to provide that sort of interface into those golden paths, into that platform itself. Depending on the maturity of the IDP, it provides several interfaces and access points that can be as basic as a CLI, it can be different kind of user interfaces, or it can be a fully blown developer portal with a service catalog to be able to unify all of this developer experience together. So what is an internal developer portal and how does it differ to the platform? So the portal here, as I mentioned before, is really, it serves as this interface through which developers can discover and access the internal developer platform capabilities. So it provides this face of the internal developer platform, and it allows that sort of self-service element of platform engineering for them to be able to access the single UI, for example, to be able to operate those operations and actions, and also offer visibility into the infrastructure through that observability that we talked about earlier as well. So it can be a really useful tool for this. So combining internal developer portals with internal developer platforms together allows us to have this sort of seamless developer experience for very quick, easy, high velocity workload and high productivity from our developers. But the key thing here to remember is that internal developer platform and internal developer portals are different things. You can use both when it comes to enabling platform engineering in your own organization. Okay, so what benefits does all of this theory bring to us as developers when we actually get it in reality? So taking a look at the organizational impact, looking at some of these responsibilities, you can see that there's a big shift from what we saw originally, Now, if we have the platform engineering team, that platform engineering team is the one that's taking on many of the key tasks when it comes to how do we deploy that application into the cloud itself, which means that developers are now freed up to focus on what they love, which is developing the application itself, enabling innovation within that application. And the nice thing is that platform engineering can help to standardize that these different elements, these different responsibilities across the organization. So we're not duplicating work unnecessarily, and allows us to have this idea of this paved path or golden path through the internal developer platform. And now the ops can just focus on the elements that they're familiar with and sort of can really be clear on which responsibilities are theirs versus the platform engineering team or development. So things like host virtualization, the hardware that we're utilizing, entitlement or billing might be shared a bit between platform engineering and ops, depending on how your team works. But really the key part here is we freed up developers a lot, taken a lot of that cognitive load off, and enabled them to have this sort of self-serve capability through a seamless experience that isn't as stressful necessarily, because they might be worried about all of those security vulnerabilities or regulations or whether they're doing the right thing. And this sort of leads into the qualitative benefits. There are qualitative and there are quantitative. And often the qualitative gets missed out, but it can be some of the most important benefits of methodologies like this. So how does it benefit development teams? Well, the first is, as I mentioned, enabling that standardization and enabling sort of secure key delivery processes through golden or paved paths. So this enables them to be able to have increased developer productivity while still ensuring that they are utilizing secure pipelines with tools that are recognized and chosen and approved by the organization in a way that is as effective as possible. It enables this through this internal developer platform, which enables this self-sustainable, self-responsible teams. So we're now able to sort of, this is arguably the most important element, I would say. And these platforms are what allow us to be able to really rapidly build and test and deploy and monitor applications with real minimal friction. Teams that are using IDPs are entirely self-sustainable and become self-responsible. They run the entire end-to-end process, and this self-reliance means that nothing is being thrown over the fence, and the ownership level increases without the friction level increasing between teams that can decrease. And then the last one is the simplicity of DevX, having a reduced cognitive load. So the fact that we're able to provide paved or golden paths can help to reduce the cognitive load and complexity often placed on cloud native engineering teams. It simplifies that vast array of different tool choices we could make into a simple list of necessary tools to master, and enables developers to be able to be more productive by spending more time focused on enabling business value. It also offers developers a safer environment within which to perform tests and experiments by utilizing the security guardrails that we were established within this platform or as part of this work. So it can really help with these qualitative sort of elements. On top of this, as I mentioned, there's also quantitative benefits. Often when it comes to changes within software organizations, we have to prove to those higher up that it's going to be beneficial and show them numbers to prove this. So here are some of the numbers that Humanitech's study actually proves in terms of quantitative benefits that we see in development teams, including wait times decreasing by 90%, average deployment frequency up by 4 times, visibility and transparency across teams greatly improved, onboarding time greatly reduced, and lead time greatly reduced as well. So this was a study that Humanitech did on teams that have built an IDP internally. That included GitHub, Zalando, Sport1, as well as teams that have built their own IDP with Humanitech's technology. And this data was evaluated by surveying these teams 6 months before they adopted an IDP and afterwards, so they could really see the difference. So you can see here some great quantitative impact on some of the organizations, but obviously this does depend on the organizational setup and size, because while smaller teams won't experience a lack of standardization and related pain points, enterprise organizations with hundreds or even thousands of developers deploying even thousands of times per day will greatly benefit from building and adopting an IDP. So this can change depending on how your organization is structured and how large it is, for example. As well as benefits to the developers, there's also quantitative organizational benefits. So as well as sort of, we can see some of the developer stats on the left there, there's also increasing benefits for platform engineering. So for example, there's a 95% reduction in configuration files that they need to be sort of maintaining and enabling, and a 75% less maintenance overhead. For the organization itself, 30% faster time to market, and 80% lower TCO for your enterprise grade IDPs. So this is all, again, this is a study by Humanitech, but there was also a recent Forrester snapshot that was taken where they found that 74% of DevOps leaders say that improving DevOps with an IDP boosted their developer productivity. 77% said that it could shorten time to market, and 85% that it drove revenue growth. So this is really, this isn't just about enabling your organization to be happier and to enjoy their job more and to enable, it actually has repercussions on the revenue that you are able to generate within your organization. However, this isn't to say that this is the magic answer to every organization. There are obviously challenges that do come with enabling this within an organization. So as well as that increased developer autonomy and reduced time to market and increased developer satisfaction, like we were mentioning, there are challenges like the fact that, so for example, many larger companies have faced issues with supporting a large organization with a very small platform engineering team. So that's a potential strain that we could come across on that platform engineering team. Sometimes it can be difficult to manage or standardize configuration or tools across an organization if there are many different sort of paved paths that are necessary. Platform engineers have the challenge of also ensuring the user configuration is precise for user authentication and authorization to be able to actually access that IDP as well. So there are some challenges still that we do need to be aware of before jumping fully into something like platform engineering, because this is still a lot of work, which we need to be aware of. Okay, but there are tools to help. Now, it's important to note that there is no single open source tool that will give you an entire internal developer platform, an IDP. But if you can, if you wish to sort of create your own, you can basically combine multiple different tools together, like things like Argo CD, Crossplane, to be able to manage your Kubernetes workload and infrastructure, with Backstage acting as a service catalog. So you can combine together lots of different tools to create your own IDP. But there is no single tool that can just magically create one for you. However, there are tools that you can utilize to be able to enable elements of them, or enable that developer portal that we showed, which is that interface to your platform underneath. As well as that, there's also reference architectures that you can follow, which can help pick which tools you want for each particular part of this IDP. So some of the reference architectures, so for example, McKinsey & Co, this bottom diagram here, they spoke at PlatformCon 2023 about their research looking at hundreds of real-life platform setups, and they uncovered common patterns in IDP architectures. They then distilled all of these patterns into 5 architectural planes differentiated by scope. So it's shown by this diagram here. So we're looking at these different subgroups of the developer control plane, integration and delivery, monitoring and logging, security, and resources. There are also specific architectures that are available. So for example, the one at the top here from Humanitech, on different cloud platforms. So if you've already bought into a specific cloud platform like Google Cloud, for example, or AWS or Azure, there are reference architectures for each of these, which are available from Humanitech. You can download the PDF to find out which tools people are using from these specific platforms for each of these various subgroups. They share the same subgroups here. So this can be a really handy tool to utilize and take a look at if you're just starting out with creating your own IDP. As well as this, platformengineering.org has also expanded McKinsey's original IDP reference architecture, the one on the previous slide, with this tooling landscape. So it's a bit like the CNCF Cloud Native Foundation landscape that we saw earlier, but this is specific for IDPs. So this tooling landscape adopts the same umbrella subgroupings that I was talking about before, but also includes other pluggable tools as well. This is a great place to start from as a blueprint, which can be really helpful to stop that sort of initial roadblock to getting started with this, because it might seem like a bit much and you don't know where to get started. This or the reference architectures are a great, fantastic place to start and to look at for you to start building out your IDP and making those tool selections to bake it all together into that IDP. On top of this, There's also other open source tooling that we can make use of. So if you've not come across Backstage, definitely go check this out. The link is there, backstage.io. This is a project that was donated by Spotify and is now a CNCF incubating project, open source. It provides you with an open platform for building developer portals and also provides this sort of centralized software catalog. And there are lots of different plugins that are now available for Backstage. Out of the box, Backstage includes the Backstage software catalog. This is for managing all of your software, so microservices, libraries, data pipelines, ML models, whatever it might be. Backstage software templates. This is for quickly spinning up new projects and standardizing your tooling with your organization's best practices. And then there's also tech docs, Backstage tech docs. This is for making it easy to create, maintain, find, and use technical documentation, kind of like a docs-like code approach. There's also a growing ecosystem, like I mentioned, of open source plugins that further expand Backstage's customability and functionality. So it's a fantastic tool to be able to take a look at to start off with. So definitely check that out. Building on top of Backstage is Janus. There's lots of different ways to say this one. This is actually a Red Hat sponsored community. It is, again, open source and it extends Backstage. So it's been developed and it's got additionally developed and enhanced Golden Path templates, Backstage platform and plugins. It's there to provide you with a highly configurable and secure development portal and that catalog to control which components can be built together, kind of like those building blocks to be able to build out your IDP. So Janus is great. If you want something that's more enterprise, Red Hat Developer Hub is built on top of Janus, which is built on top of Backstage. So kind of going all the way through it here. One note on this is that it's only available currently to a limited set of customers as a preview, but it is hoped that this will be out fairly shortly. But if you are interested, Janus is obviously the underlying open source, so you can go and check that out to see what Red Hat Developer Hub might be like. But this is really focused on that enterprise grade sort of quality in terms of providing a product for those enterprises who want something like this. And it allows an open developer platform for building open developer portals. It contains a supported and opinionated framework offering some of those sort of golden paths or paved paths, and it offers extended functionality through a set of predefined supported plugins. If you are interested in finding out more, there's a really great YouTube video on the bottom right, which gives you a preview into what this tool offers. They are hoping that it will be out, generally available in the second half of this year, which is obviously kind of coming to a close soon. So we're hoping it's going to be out soon. But this is a really great project to take a look at if you like Backstage and Janus and want something a bit more ready for the enterprise. Another open source tool is Kratix. So this is an open source cloud native framework for building internal platforms specifically on Kubernetes. You can go check it out at kratix.io, or there's a really great enlightening video from Whitney, which I've linked to at the bottom here, where she goes through it with one of those light up light boards and really details out the sort of ability and features and functions of Kratix. What it allows is for us to be able to co-create capabilities between development teams and platform engineering by having this sort of premise of promises. A promise is comprised of three elements: an API, so input from an app team to create resources from a capability, a set of dependencies necessary for any created workloads, and then workflows, so business logic required when a resource is requested. So this sort of promise, all these three elements, is what allows us to be able to create the IDP and enable these paved paths as promises. It supports platform teams to be able to easily deliver this sort of curated Kubernetes native platform API. So another open source tool that's really interesting. Other options that are available, there are already proprietary options that you can go and check out and see if you like the look of. So things like Port, for example, Configure, Cortex, Rody, Compass, there's loads on here. There is a list in the link that I've got at the bottom of this. internaldeveloperplatform.org has a list of some of the potential available. Many of these are offered as SaaS or PaaS. So if you are interested in more of a pre-curated, pre-built platform that's supported for your enterprise application, then these might be an option you'd want to consider. And that is something that's worth noting, is that there is a wide array of different IDP implementations when it comes to actually implementing this in your own organization, all the way through from sort of just starting out, getting your platform engineering team up and running, through to creating, a specific IDP to your organization that's completely made from scratch, all the way up to utilizing some of these PaaS and SaaS offerings, sort of pre-built, pre-configured, available to you. So do bear this in mind that you might fall somewhere on the spectrum. No place is necessarily the right place. It's different depending on your own organization and how you're set up. The important thing to consider is that just because a lot of people are building platforms does not mean that it's easy to build. This is not an easy alternative. This is an effective alternative, but it does take time and work. Most developer platforms aim to reduce complexity and give that self-service access, but the balance is paving this path is different for every organization, particularly when you consider the fact that there are different kinds of developers in different organizations. Developer platforms are not there, internal developer platforms are not there to cater for every developer in your organization. It is there for the 99% developer who build most of the real world applications, often rely on legacy software versus the sort of vocal minority or developer influencers that might be doing the super cool stuff with innovative things. They might need to sort of build on top of the IDP themselves and take responsibility for that. IDPs are there for the 99% developer and aren't there to provide a golden path for every potential thing that you might need to. So it's important that you strike this balance between how many golden paths that you offer through the IDP and that you strike this balance between how much of that do you want to create yourself versus how much of that can you get from open source or other frameworks that are available out there. Okay, so where is this sort of heading? Where is this going in terms of the future? And this, I think, is based around two different questions. The first is this whole, how much should you be building yourself? And the second is, how should you be assembling the control plane as well? So I think there are three avenues for future innovation within this space. The first is this idea of sort of ready to go golden paths. I think we're going to be seeing more and more companies offer predefined, pre-configured golden paths for us to be able to pick up and go with. It's all well and good when you're a really large organization, being able to put in the resources, put in enough people into your platform engineering team to build completely custom IDPs. However, when you're a slightly smaller organization, it can be difficult to be able to have enough people, have enough expertise, have enough skills to be able to create that completely from scratch and completely custom. And so I think we're going to see a lot more people looking for pre-configured, ready-to-go golden paths from different organizations or runtimes or platforms. Another way in which I think we see the future here is persona expansion. Right now, we're pretty much solely focused on developers because they are the primary user of this platform. However, in the future, I see sort of this persona expanding to perhaps other close supporting roles other than just dev. So things like enterprise architects, QA engineers, data engineers, or even people further afield like security or finance or HR. The fact that we have these fantastic insights and metrics that we can collect through the portals and platforms, all of these other supporting roles could also utilize. Many of them often rely on manual data collection analysis. So maybe being able to use a self-service portal with access to that infrastructure and applications could enable them to also be more effective and productive and even maybe gain further insights. And the last one is this idea of programmatic. It's kind of, I guess, another persona, but in this case, we're talking about machines, sort of allowing them to also consume that data. So could they use this plethora of data or analytics to help businesses or departments drive decisions, for example? Could it be used to make decisions on pipeline executions, not just using APIs to push data in, but also pull data out and drive processes within your org, linking it maybe into AI and machine learning as well. So I see lots of avenues in which this could develop in the future as well. So with that, I'm just going to quickly summarize and give you some of those resources that can help you take this to the next step and further your learning and further your development within this space. So hopefully from this presentation, what I've shown you is that, yes, our cognitive load and the demands on developers are ever increasing as we move towards modern cloud native Java development. However, developers can be supported and helped through these various different methodologies and platforms. So platform engineering, internal developer platforms, internal developer portals, and the ability to access those golden or paved paths. Now, what this looks like will be specific to your organization. How much do you want to build yourself? What is your team structure? What does your development need? All these questions will come into play with that. But you can utilize the tools, the technologies, the reference architectures, and also examples from other companies that have already started this journey are already out there for you to utilize and refer back to when you're starting out on your journey within this space. That kind of leads me on to my resources. So as I said, there are lots of different examples out there of organizations who have already started on this journey that you can learn from. We've obviously got the big companies like, for example, Netflix and Spotify, who have helped to sort of engineer and create many of the open source tools that are now available in this space. However, there's also smaller companies here, or mid-sized companies like, for example, Sneak, Twilio, and smaller companies like the Veterans United Home Loans. So there's some really great resources here for you to check out to see how have other companies done it, what choices have they made, and how have they achieved that, and what benefits have they gained from it as well. There are some fantastic resource references that are created by the various different companies like Configure, for example, Configure 8, and also some of the other companies that offer those proprietary products that we went through earlier and those tooling. They do a lot of different podcasts where they have recordings with a lot of these companies who've started out on this journey. So do go and check them out. In terms of resources specific to platform engineering, there's a growing community within this space, and thus a growing number of resources that you can refer to. So the guys over at InfoQ have created this very useful platform engineering guide. You can download it as a PDF. So do go and check out that first link if you want sort of a summary reference of what I've spoken about today to be able to show to your team and say, this is platform engineering. I think it's great. Maybe we should try it. There's also things like PlatformCon. I've mentioned it a few times in this presentation. Some of my links do link to recordings. This is a conference that is created literally around the platform space, and previous years' sessions, their recordings are now available freely on YouTube. A lot of them are about 15 to 20 minutes long, so not too long. They get straight into the nitty-gritty, and you learn a lot in a short space of time. So I'd really recommend those session recordings. There's also a platform engineering Slack channel that you can join, and a weekly newsletter, Platform Weekly, as well, if you are specifically interested in signing up to those. Otherwise, here are some additional resources, just in case I hadn't given you enough homework already. So things like the benefits of platform engineering. That first link is helpful for that if you want more in-depth insights, as well as the ones that I referenced in the qualitative and quantitative slides. There's also a link here from Configure 8, one of those proprietary providers, listing out what is the difference between a platform and a portal. Just in case that wasn't entirely clear in my presentation, you can refer to that second link. Tools for your IDP creation. There's a really useful Medium blog here that you can go and check out for that. And then IDP reference architectures, you're available in that second to last link. And also looking at what's next in terms of this space, a really great video from the PlatformCon 2022 edition from Daniel Bryant, who's one of the leading experts within this space. So do check that out. It's only about 15 minutes long if you want to go further into the future element of this specific topic. But hopefully those resources are useful and sort of cover right from the very start of like, what is it, through to why does it help, through to how do I do it, through to what's next. So covering the various different elements we've looked at within this presentation. So with that, I'm going to say thank you so much for joining me and sticking with me through this presentation. Hopefully it's been useful for you. We'd love to have feedback. Shout out on Twitter or LinkedIn or in the comments here in the chat, and I'll take a look at them. Really appreciate your time. If there's anything I don't get around to, do contact me on either LinkedIn or Twitter. I'll be there to answer any additional questions you might have. Thanks so much.
Yeah. First of all, I want to say thank you very much for this great talk. I have no words. Just awesome. Thank you very much for bringing it to us. So we have a lot of not of questions, but I would say more comments about this talk. It looks like audience is attracted. So if you want to know, we have around 800 people looking at us right now. So yeah,
that's amazing.
Yeah, so not all of them are really active. So guys, I encourage you to leave your comments. If you don't have questions, just put some smile or anything to the chat. So we would really appreciate that. So Evgeny, let's start from a question from YouTube first.
Yeah, let's go through the questions. And Grace, yes, thank you so much for your talk. It was amazing. So regarding the question, one of the first
Okay,
I've lost him.
Yeah. So we have some freezes. So yeah, this is online conference, guys. Everything can happen. So let me grab this. let me grab this stone here.
Sorry, sorry for that.
Evgeny is
Yeah,
back.
so there was a kind of the glitch. So yeah, so first question that I would like to ask you is regarding your day-to-day activities and the tools that you use on the daily basis, especially that might be related to this talk for the internal development platforms and so on. Are there anything that you may suggest, maybe that is created by IBM or a kind of a team kind of the tools here that are highly used by your environment around?
Yeah, so my team mostly work on an open source runtime called Open Liberty, and I definitely, please go and check us out. I run the Open Liberty socials, so I'll say hi if you come follow us on social media, either Twitter or we're on LinkedIn. It's a cloud native runtime that can really help if you're looking at developing cloud native Java applications. It's modular, really lightweight, and it interacts and implements many open source standards like microprofile and JaCoV EE. So please do go and check that out. It's openliberty.io. We have a bunch of interactive guides there that you can even do online. So you don't even need any prerequisites locally, which is great. We're super proud of it. So please do go check it out. We'd really appreciate any feedback you have on it. But yeah, go check out Open Liberty. It's on my t-shirt.
Yes, that sounds great. Yeah, thanks so much.
Yeah, and I want to give a comment. So guys asking in chat, like, where can they find slides? So we will ask Grace to send us the presentation, and we will pin it to the talk on We Are Community Platform. So you can find link to We Are Community Platform in the description on YouTube, if you're on YouTube, or if you're on We Are Community Platform, you know where to search for. So there you will find the presentation and all the links, and thanks a lot for so many resources. Yeah, it's really, really awesome.
Glad it could help. I'll definitely be sharing them.
Yeah, so we also have more questions on the platform. So question is kind of provoking, but I will ask it. So could you possibly estimate to what extent using platform speeds up the delivery?
So if you go back to my quantitative, I believe that's one of the ones that we saw in there. Yeah. So for example, average deployment frequency, this is up by 4 times. So instead of just being 1.5 times a week, we're up to 6 times a week. So you can see this is real data from real companies implementing IDPs from Humanitech survey. So a 4 times increase, which is great.
Okay, and second one, even more provocative question, I would say. So it's just scroll on. So does using platform make developers happier?
So I think there's always going to be someone in your organization who doesn't like a change like this. Not all of us are excited about innovation and change, and we like the way we've been doing it for many years, and that's understandable. However, I think most developers would be happier to know that they can just focus on the application code and developing innovation in that space. Because if we wanted to be in ops, we'd probably be in ops rather than in development. So I think on the whole, it does make for happier developers because they can just focus on the application code.
Yep, that sounds great. So I guess that is all from the questions from the chat, but I have my own one.
Yeah.
Actually, as far as I have got experience of working with the platform teams, there is a kind of the thing that always makes me annoying, and yeah, that is a good time to ask such kind of the question to you. When we are talking about platform teams, they are working on some kind of the platform features, right? And that is so great when I require it in my team. Yeah, from the front end perspective, from the back end perspective, it doesn't matter. But they have their own estimations. What do you have a kind of the receipt how to efficiently negotiate with them? Yeah, to push it to the top of their priority list.
Yeah, so that's actually one of the good things about Kratix. So that was one of the open source tools that this one here, because it is really that co-creation between development and platform engineering. Because you've really got to think about the fact that in this, like in IDP development, you've got to think about your developers as your clients. So really, you should be developing a platform that suits their needs best. So it should really be a co-creation between the two of you. So this particular tool allows you to be involved in the prioritization of features through the use of those promises. So if you're interested in that aspect, I'd definitely check out the Kratix tool.
Okay, yeah,
Yep.
and I have, I think, last question from my side. So yeah, we have a lot of comments like, thank you very much for the presentation and brilliant talk. So yeah,
Thanks,
people really
guys.
enjoyed it. Yeah. So last question from my side. So I remember, I think around 10 years ago, there was kind of such talks about DevOps practice.
Yep.
So there was like this, okay, guys, so we're struggling, right? There are developers, there are admins, and now at like IT, and now we have something, should have something in between. So now we're speaking about having something in between devs and SREs, basically, which are now DevOps, right?
Yep.
What are your forecasts? Will we have in the future some more talks, maybe even from you? Like, okay, guys, so platform engineers is, yes, they struggle. Now we should have something in between. What do you think?
I think it's inevitable because all of this is evolving at such a fast pace that we're never going to get it perfect first time. So we've got to be flexible in understanding that our organization structures might change, our responsibilities might change, the way we deploy applications might completely change. Who knows? But that's what's exciting about being in software development, is because it changes so fast, so quickly, and so with such great changes and great results. So I think it's kind of inevitable that we will have another talk in 10 years' time, but hopefully it will be for the benefit of all of us.
Okay, sounds great. So we'll wait you for with next talk.
I'll be back.
Great. Thank you very much. Thank you very much for this great start of the conference. Thank you very much for your talk. And yeah, we have a lot of comments for you to get well very fast
Thank
and
you.
soon.
Sorry.
So yeah, no worries. You did your like very best, and we're really glad that you still with us. So thank you very much for this talk.
Thank you, guys.
Thank you.
Thank you. Bye.